Kyle, Albro, and I decided to work together on our final project for CSCI 255 to do sound generation. The basic premise for ours was non-harmonic frequencies, i.e. two frequencies that clash with each other in such a way that make a very distinct sound, and they are very distinguishable from one another. We are using the MSP430G2553 microcontroller as the main microprocessor for the project. And the basic setup, we also use the dev board from the CSCI 255 class and speakers for the actual playing of the sound. The basic setup, we use the bottom pins on here to link to the 16-key keypad on the dev board. We use the latter halves of ports 1 and ports 2 on the microcontroller, respectively, and one generating the inputs and outputs for the reading of the keypad. The top setup here, we have a common ground between the speakers and the microcontroller, a common ground between the dev board and the microcontroller, a 3.3 volt power connector between the dev board and the microcontroller, and we are using pins 1.2 and 2.2 for linking for the actual generation of the sound through each speaker. The basic premise is that each column and each row of the keypad, when pressed, emits a different frequency. What that means in practice is that when a button is pressed, it emits a unique sound based on its row and a unique sound based on its column at the same time. These sounds are non-harmonic frequencies. This is designed so that each frequency can be individually picked up and read by a person or machine, and what it means in practice for at least the human ear is that each button makes a unique sound. The historical use for this was at the advent of telephones and phone numbers. The point being is during sometime along the development, the previous system was becoming detrimental with different people with more manpower needing to read numbers coming in and calls happening constantly. The premise behind the non-harmonic frequencies is that each frequency can be read by a machine, or so that they can generate a number sequence, since each number, and it was kept uniform across the systems in which it was used, emitted its own unique sound, so that when that sound was read in across the transmitter, the machine knew which key was pressed, and they read the sequence of keys to generate what the phone number that was being dialed was. That's the basic premise of why non-harmonic frequencies were used in this way. I hope you enjoyed our video and were able to understand our project, and you have a nice day.